Ever since I was a little boy, I have been very passionate about building scale models, but I have never imagined that one day I would be building high-rise projects in one-to-one scale as my profession. Super high-rise building is like Formula One car. The engineers push everything to the boundary, and the rest of the industry can learn from it. And this is what we have been doing for all the tall buildings projects in the world, such as Merdeka 118 in Kuala Lumpur, Malaysia, Taipei 101 in Taipei, Taiwan, and Burj Khalifa in Dubai. All these three buildings have one thing in common, that they are all very tall, but they are all designed differently. Taipei 101 is a structural steel design. Burj Khalifa is 99% reinforced concrete design. And Merdeka 118 is a hybrid combination of the two. So I joined Turner in 2000 as a concrete superintendent for the project at Taipei 101. At the time, it was going to be the world's tallest building. And that's the beginning of my high-rise career. After Taipei 101, I was asked to join Turner again in Dubai for Burj Khalifa. And now I'm in Merdeka 118, Malaysia. So I always say that you never say this is a once-lifetime project in Turner, because I have said that 3 times. As far as I know, there are just a handful of people has been working in 1 or 2 of these 3 buildings, but I am the only one who has been built all these 3 projects. From the very beginning, the building owner has a clear goal to make sure that this is not the tallest building in the world, it will be the greenest super high-rise in the world. For example, the glass is coated with low E coating and titanium coating that would effectively reduce the UV ray coming to the building, reduce the heat. We also have 100% rainwater harvesting tank that will be able to capture all the rainwater, then we can use it for irrigation and toilet flushing. We also have a very unique design that the cool air is coming from the floor, and we have a very unique chill water system that can store chill water in the basement, which can store more than 35,000 cubic meters of chill water. That's equivalent to 14 Olympic size of swimming pool. The real challenge is that you need to finish a tall building in a certain time frame. That's when you need to be experienced, sometimes be creative, well planned to get it done. So time and money is actually the big element here. Doing that is not a problem. Doing that within your budget, within a time limit, is a challenge. Yeah, it's perfectly possible to construct and design a building more than 1,000 meters tall. There are certain technology constraints like vertical transportation. You won't be able to move people all the way up for 1 kilometer. And fire life safety is always a big issue for the people living inside the building. So yes, engineering possible, but feasibility, a big question. All the designers, they can have safety factors in their design, what we call redundancy. Right? The structural engineer will put 1.5, even 2 as a safety factor. You can only take risks if you have confidence and knowledge, experience, that you know that you can do the job. When I finish 101, it's like, wow, you gotta go to the next one, because it's a tall building. It's very natural to you to continue on. But every building is different. They have different design. They're building in different countries. So they are general principles that you can apply project to project. But since they are all designed differently, the construction methodology might be different, the approach might be different. So I would never say that anyone in the world that can duplicate one experience to the next one, because every tall building are so different. You will definitely encounter different challenges anyway. And that's what makes the project interesting. I would say the roof is one of my favorite places of the building, because from here, I'm actually looking down the other 3 high-rise buildings in town. Of course, it made me proud. Yeah. how often you can actually look down at the X tallest building in the world.